So very quick and short video. The other day, like 2 months ago, I tried to attach this drive to a USB IEEE interface to get it to run with that. It worked for a couple of minutes and then it died. Especially this drive here died, the drive 0, which was pretty annoying. Seems the head was going forward too much and got stuck. So I managed to get it free again and it's now working again. However, when I tested both drives, suddenly I noticed that drive 1 was not formatting disks anymore. I was again getting the speed error. I thought this had gone away when I exchanged the voltage regulators, one of which, the yellow one you can see here in the back, because it would get more power basically to drive the very old motor. So I thought maybe the motor is still bad or something. And usually you can open up DC motors and check for the brushes if they are still good, or do some lubrication work or something like that. And these drives have these kinds of motors, which are 12-volt DC brushed motors by a German company called Bühler. But they have used to have a factory, I'm not sure anymore, in North Carolina in the US. You can see this is the motor that was used because it has a drive pulley that has a lot of dirt on it from the belt actually. And I thought I could open this up. This part here is the bottom, so to speak, where the so-called tacho in English, I don't know. The drive speed indicator is basically because you get both the DC blue and red wire, 12 volts in there, but you also get a feedback, the green and yellow wire, which tells you how fast this thing is driving, being driven basically. And the circuit here can then regulate it so it has a constant RPM. And you can tune this with this little trimmer port, and over here is one for this drive as well. So that's the idea. So I opened it up. Up here, I bent open these tabs. And two things, it seems it was all fine. There was no dirt in there. Everything was super. And also the brushes and the springs were jumping out. And now I can't get it back together, which tells me not to have done that. Slightly annoying. So it looks, from the inside, it looks like this. Here you can have a look. This is the rotor basically in the middle. Then there's a permanent magnet around it. I think the brushes belong in here with the springs into these little boxes, but I can't get it in there anymore because it has to fit over this rotor thingy and not the axle, which would have been okay to put it over there. But I think they assembled it this way around, that they first put the brushes in with a jig or something in the factory, then pressed in the rotor, put over the whole stack this case, basically, I guess, and then they put the top package with the sensor in it, or the sensing equipment, whatever. It's probably just a few coils or something on top, pressed that in here and did some press fit or something of the pulley. I can't get this off. Otherwise, it would probably be possible to reassemble this in exactly the same fashion. So for all intents and purposes, I destroyed this motor. Maybe I can figure out a way to repair it still, but right now I can't. What I did instead is I bought a replacement motor. However, actually I got a couple for very cheap, but they're gone now, basically, and I don't think they make this exact motor anymore. There are similar replacement motors for quite expensive, like around 60 bucks, and they are missing the drive, the belt pulley. And also, if you take a close look, the pulley on the new motor has a bigger diameter than the old pulley. It's also a bit well, not as tall, let's say. Yeah, this is a problem because the bigger pulley means there's a different gear ratio basically between the pulley down here and the big flywheel, plastic flywheel or stroboscopic wheel thing here, the drive wheel actually. So this thing was running way too fast. Okay, next problem to solve. For that, there's the trimmer pot, so you can slow the drive down. Problem was, it was already at its minimum setting with the original motor. I could only make it run even faster, so that's an issue. So I looked at the schematics and figured out that the whole drive circuit feeds into this op-amp here. Both drive circuits actually feed into the op-amp. And the comparison rail basically, which compares with the voltage that you adjusted with this trimmer pot, goes first to a 10K resistor here and here for each line basically. And I thought, well, if I can't get this trimmer pot to go even lower, I can lower the leading resistor basically. So what I did, and I'm gonna take you there. Let's zoom in a bit. What I actually did is I put in a parallel 100K resistor here, the blue one. So both together now have roughly 8.9 or 9 kilo ohms, thereabouts of resistance. So I can get the pot even a little bit up into the actually positive resistance thing and make the drive go slower. So I used that. I used this exact camera app here on 50 Hertz to align the speed that the center strobo disc thing is stationary. And this means that it has, at 50 Hertz, it has exactly 300 RPM, which is exactly what we want. So I did that, and suddenly the floppy drive worked perfectly. It started formatting disks again, and yeah, that's it. So very, very nice. We can try and have a look. I'm gonna turn both the pad and this machine on. I think I have connected everything correctly. Hopefully. The thing is booting up. A disk is in there. I will close the drive. And let's type in directory D1. And yes, there you go. Have a look. Oh. There it says directory D1. And we can even try and type in a little program. So I'm going to put you down like this. Let's do a 10 print hello world. Run. Wonderful. Be safe. Hello world dot bash. Comma D1 should do the trick. Drive is running. Another directory D1, and there you go. It's loading and saving with no issue. I'm not sure that you can see the strobo disk here very well. Let's try and do another directory. Yeah, it's hard to see on the current setting. I think the shutter is too long, but the central ring here should look relatively stationary, if you can see that. And that's exactly what we want. Only thing that we should also try, which I haven't tried yet, is to actually read from the other drive. However, there's one issue. I haven't connected the read head yet. So let's quickly do that to see if the disks that are formatted in this drive also works in the other drive. So let's turn this off for a second, because I don't want to attach the disk head, drive head. Okay, and this has to go which way around? Where is the empty pin? It's always a trick question. I think it's like this. No, Can't be, can it? I don't want to destroy anything. Oh yeah, this is the empty pin, it seems. Yeah, this should be fine. Let's turn on the drive again. Insert the diskette. And zoom out a little again, so that you can see both. And now let's do a directory D0. Yes, it can be read. Let's see if we can load something. Deload hello.das, comma D0. Seems good. List, it's all fine. Yeah, seems we have a working drive now. I didn't do the same mod on this drive, although it's also at the almost at the very minimum of the trimmer pod. I'm gonna leave the motor as it is because this drive has no issues formatting disks. It was only the other one that had the issue. And we've solved it now because now we have a new motor and a well-calibrated motor, let's say. And I think this should be able to run for many more years. I hope. So I will completely reassemble everything, put everything back where it belongs. And I think finally this thing should be fine to work. I'm gonna think twice about using the USB floppy interface with this thing, maybe to just copy single files. I tried a disk image, maybe that was an issue. But that will be something for another video. So this is just a very quick update, already going to 12 minutes. So yeah, thank you, share, like and subscribe, and see you next time on this channel. Bye!